My name is Jeannie Morris, and this is my Exercise 8 presentation. We were first asked to use the data in Figure 8.1 and build a confusion matrix. So in this example, we are using the data from the Titanic. And this is what it looked like when I did put in survived as the response and then used all of the other variables present. And it asks us to build a confusion matrix, which is this diagram down here. So here is the confusion matrix enlarged, and to get a better understanding of it, we can go to, we can expand and look at the details of the confusion matrix. So here we see that when it was predicted that they would perish, and it was also observed that they would perish, it was 87.25% correct. When it was predicted they would survive, but they ended up perishing, it was 12.75% correct. When it was predicted they would perish, but they actually survived, it was 26.15% correct. And when it was predicted they would survive and they actually survived, it was 73.85% correct. And then we were asked to calculate the precision, specificity, sensitivity, accuracy, and F1 score of the decision tree. So we're actually going to go into SAS Viya to do this. So here we have the information. Let me make sure that it's correct. Yes, 8.1. So we're going to maximize the view and look at these different items. So first, let's go to the assessment statistics, and we'll see the F1 score is 0.760. Then we can go over to ROC, and we'll see the sensitivity and specificity. So here we see that the sensitivity starts at 1.0 and it declines all the way down to 0.02. With the specificity, it starts at 1, and then we see it declines all the way down to 0. And here we have the different cutoffs. There's also some other things that we can look at, like the confusion matrix. This provides the accuracy of the predictions made. Here we see the importance of different variables used. We have the node statistics, the observations both in numerical form and percentage, predicted values, and then the percentages of those. So now we're going to go to exercise 8.2. And we were asked to use the employee attrition set to create a decision tree to predict attrition, and that is what we have done. This specifically is the decision tree. And it asks, what predictive model does SAS VA propose? So we can find this by going to the node rules, and we see that the different variables that it used were gender, job role, education field, department, and business travel. And then it asks, what interpretation do you make of the model with regard to the predictors? So here we're going to go back into SAS Viya and take a look at the decision tree. So the decision tree is currently in interactive mode, so we can hover over the different boxes. And this is looking at overtime in relation to total working years. And we see that for yes, it is 8.39% that total working years of less than or equal to or greater than or equal to 3 and overtime being no. We can then look at age to see if this is a good predictor of attrition, along with monthly income. Over time is set at yes, monthly income of 1,009 to 3,919. So does this have an impact? The answer yes was 53.74% and no was 46.26, which is a pretty even split. Then we see if job role has an impact, and we see that people answered no at 82.16% and yes for 17.84%. And you can just hover over these to get a better idea of the impacts of these predictors on attrition. Then it wants us to analyze the confusion matrix and comment on the performance of the model. So we can do that here, the confusion matrix. So for those that it was predicted no and observed yes, 147, which is about 62%. When it was predicted no and also observed no, it was 97.89%. When the prediction was yes, but we observed no, it was only 2.11%. And then when it was predicted yes and observed at yes, it was 37.97%. So overall, this did a pretty good job, because when looking at what was observed and matched up with the predicted, we see when it was no and no, it's almost at 100%, so that was a really good predictor. And when it was a yes and yes, it was about 40, which isn't great. We would like it to be over 50, but it's still not terrible. We can also maximize this view to get a little bit more input. Let's see, so usually the cutoff for KS is at 50%, so it is a little bit low, but it's almost there. This is what we were looking at, only in a chart form. There's a lot of different things we can look at to get a better idea of this. And then it says, how well does the decision model perform compared to the logistic regression model you created? So here we see with the decision tree, like I was saying, you do want the KS to usually be over 50%, but this isn't terrible. And then looking at the logistic regression, we did the same thing as with decision tree. If we look at our roles, we put attrition as the response, included all of the continuous effects available. And here we see that using the logistic regression is actually a bit more accurate, as it does exceed the 50% cutoff. It's at 57%. So we can say that the logistic regression did perform better. This concludes my exercise 8 presentation, and I hope it was helpful.